is nothing but just if we leave any body in the air, automatically that is considered as a free fall because we need not apply any force on it. Just if we hold whatever the object we hold it in our hand, we just leave it without any particular force applying on it. Automatically, due to the gravity of Earth, that is the attraction between that body and Earth, automatically the body moves towards Earth. And once
Okay,
it
sir.
reaches Earth, that is only the free fall. In that case, generally from any height, if we just fall a body, automatically due to its gravitational force, the body falls down. This is called as the free fall.
Yes, sir,
So
I understood.
they gave particularly in the bracket no with no other forces acting on. No other forces acting on it means that when we left the body, we suppose you're not giving any particular force at the starting point.
Yes, sir,
Even though
I understood.
it just falls down without any force. Then Pranay, the acceleration of an object falling freely towards the end does not depend on the mass of the object. Yes, Pranay. The, ac- the
Yes, sir,
acceleration.
because when the object is dropped, its mass is 0.
No, Pranay. Its mass will be always same, Pranay. Mass
No,
will
sir,
not.
our teacher said that when the object is dropped, its mass becomes 0, but then when the, like, yeah, he said that.
No. Mass can never become zero. But if suppose what will happen is if suppose any object moves with infinite speed, infinite means like so much fast. Because of the frictional forces or something, the mass gets completely. There is like the body of the mass of the body gets converted to some energy, but it's impossible to mass become zero. But I think maybe any other something else will become zero.
No, sir, he said that mass will become 0.
In which case, okay,
When an object is dropped, its mass will be equal to 0. But then when a heavier object is dropped compared with a lighter object, the air resistance acting on the heavier object is more. So that's why it will come down fast. No, it's lesser. So that's why it will come down faster.
actually, if it is very light particle, okay, very light, like simply to tell if the means like it's so light that the air can stop it from falling on the ground, or except those bodies. Actually, mass becoming zero is impossible, okay, because it is possible in which cases is because of the air force, whatever because of continuous movement of that, if with high, it gets converted to energy few cases. But normally free fall body cases, like generally mass, when the body falls freely, initial velocity is zero. Okay, Pranay, here they're talking that they're telling that acceleration with which a body falls towards the earth due to gravity's prism. The acceleration of an object falling freely towards the earth doesn't depend on the mass of the object. Means whether we fall smaller object or bigger object, acceleration due to gravity on the object will be same. That is what the
Sir,
meaning.
I'll ask my class teacher about this tomorrow.
Oh, okay, Pranavi. In which case he said that mass will become zero. Maybe if the very lighter particle things, Pranavi, if they travel with so much speed, in that process, what will happen is because of the frictional forces that in the process of movement, it gets heated up, and that the body mass gets converted to energy. Energy means it gets like evaporate, like suppose water, how it will evaporate, like that. The mass gets converted to energy because of the huge amount of heat in the process of movement.
Okay, sir. You can go to the next topic. I understood.
Yes, but Pranavi, this one again you will ask and you will confirm because I also just want to know in which case is like that.
Okay, sir.
Okay, Pranavi. So the freely falling body has acceleration equal to acceleration due to gravity. Yes, Pranavi. So we already know this one. Freely falling body acceleration is due to the gravity, no? So that's why
Yeah.
A is with Now they are explaining clearly acceleration due to gravity. Okay, what is it? The acceleration if the body falls towards due to gravitational pull is known as acceleration due to gravity. Simply, we can write it in our own words also. Whatever the acceleration gained by the body in freely falling case is due to the gravity of the earth, is gravitational pull of the earth. So because of that reason, we will call that as acceleration produced due to gravity of the earth.
Yes, sir.
It is a vector quantity because it's always it has a direction. Okay, so vector quantity is a quantity which has both magnitude and direction. Magnitude means a numerical value. Direction means like plus or minus that will give in one particular direction it acts. For this acceleration due to gravity is always in one particular direction. Suppose if we take any opposite direction to that, we have to write minus. Magnitude means numerical value. Direction means like we know already here G is always towards the earth, like that one particular direction. Therefore, vector quantity. If it is a scalar quantity, means just magnitude, no particular direction.
Okay, sir.
And SI unit of G is again meter per second square. Direction of G is towards the center of the earth. This is only the direction. Just now we discussed about vector quantity. Its direction is always towards the center of the earth. It has a particular direction. G value. Acceleration due to gravity has both magnitude, that is 9.8 is magnitude, and its direction is always towards the center of it. So because of that, but that reason it's a vector quantity. Okay.
Yes, yes.
And finally, expression for the acceleration due to gravity. We already wrote this one. F is equal to ma. Like yesterday here, that a gets replaced with the g.
G.
So now, yes, in this, if you this F is equal to ma actually comes from Newton's second law. Because Newton's second law is nothing but rate of change in momentum. When we derive that equation, finally you got F is equal to ma.
Yes, sir.
So if we apply the same thing for this situation, the A gets replaced with G in that formula. F is equal to mg in the this attraction related process. So the magnitude of gravity on a body is given as where m is equal to mass of the earth. We know that suppose this formula we have it. We F is equal to g m1 m2 by r square.
Yes, sir.
So m1 is m1 and m2 are both masses. So in that masses case, what will happen is one of if suppose if you are following a body on the ground, the two masses will be one is earth and another is the body, the one which you are following.
Yes, sir.
So here because of that reason here this m1 m2 like I said in cases will write small m capital M like it also yesterday when I was doing. So m1 m2 capital M small m our register. So here capital M generally will take it for the bigger mass and small m is a smaller mass. So most of the time capital M here in this case X and object case F is capital M and small m is the mass of the object which you are following and R is the radius of the vector.
Yes,
So
sir.
yes. So from Newton's second law of motion, F is equal to mg. There's some steps are missing here. Yes. So now what we can do is quickly what will come here and so for example, if suppose here we can just write what they're trying to find out is okay. Just a second. Where is the equation?
Sir, actually, can you send the derivation of the three equations of motion? Like I don't have them
Means
from the second chapter.
okay, V is equal to U plus at S is equal to U plus half at square and that works. Okay.
Yes, sir.
Okay. But when we said that the chapter is not there, only post laws of motion.
What?
Only Newton's laws of motion is there. We said that chapter is not there. Is well.
The chapter is there.
So that also is there. Okay.
Three chapters are there.
Okay.
Sir, so after we're done with the gravitation, can we do some numericals on this and some numericals on the second chapter also?
Nice. But we here, this experiment, we will do it. Okay? Immediately after this, I think mostly the next part is just differences between small j and capital J. And in this worksheets, in some places, Pranavi, then the chapter is finished. Pranavi, only numericals.
Okay, sir.
Actually,
Actually, I mainly need help with the numericals because I may do like many mistakes with the formulas.
yes, yes, Pranavi, you need that.
I need the help with the numericals because I keep doing mistakes with the formulas and everything. The theory part, I mostly understood it. So, sir, can you complete like the rest of the theory part in like 5 minutes? There's not much left, right?
Yes, Pranavi, that is correct. Here, actually, in between somewhere or the other, some print is not there. So what they're trying to tell here is, suppose in this case, F is equal to mg, whatever the force that acts on that body, m is the smaller of the one that is moving front. Okay, so if you observe that whatever the force that is generated on that body because of the movement due to the gravity of it, that force is nothing but g capital M small m by r square. So if you because the reason is F formula is what going to be g capital M small m by r square. No, this F is here mg.
Yes, sir.
MA gets replaced, A will get replaced with G. So both sides small m capital M will get that. So finally we have G is equal to G capital M by R square.
Yes, sir.
So here this is what missing there. These two steps, these steps are missing. Mostly those
Oh,
only will.
yes. Okay, sir.
Yes, Pranay. So now from this equation, what we can understand, Pranay, G is directly proportional to the mass of the earth. It is irrespective of whatever the smaller object you are falling on the ground, you are making it to fall on the ground. That one, in the final equation, we don't have that mass at all. How much smaller object you fall, or like how much smaller object we fall in, and a bigger object it fall. In the final equation, there is no small m in the. From this, what we can understand is that acceleration due to gravity g is only directly proportional to the Earth's mass only. Okay, Pranvi?
Okay, sir.
And inversely proportional to the square of the radius of the Earth. So the value of g is different for different heavenly bodies. Understood, Pranvi, what I'm trying to do?
Yes, sir. I understood.
Okay, Pranvi. For any object, finally, in the equation when we do it, no, there is no small m in the final equation. Acceleration due to gravity. In that equation, we don't have the smaller the object which we are following. No, that mass is not there. Only capital M is there. That is mass of the Earth is there, which means that G is completely dependent on the mass of the Earth and inversely proportional to the, because R square is in the denominator. It's inversely proportional to the square of the distance, square of the radius of the Earth.
Yes, sir.
Okay, and we already know value of G is different in on different heavenly bodies. So since mass m, that is heavenly bodies, mass will vary. No, automatically G value will vary. Because
Yes,
on
sir.
Earth it's 9.8 meter per second square. On some other planet, this m will vary, so automatically radius also will vary. So G different G value.
Okay, sir. I understood.
Okay. And note some points are there. Okay. Value of G decreases with the height from the surface of the Earth. Means what when we go so far from the Earth's surface surface, so automatically distance increases. So the gravity will reduce.
Yes, sir.
So that is what those points. Value of G decreases as you go deep into the crest of the earth also. Even that in that case, what will happen is radius will
Yes,
actually
yes,
the
sir.
mass.
Sir, actually, our teacher said something like he wrote the F is equal to G M1 M2 by R square formula. He said that if force is doubled, something will also be. He said that if the distance is doubled, then the force will be by 2. Something he said that.
Actually, if distance is double Pranavi, force will become, if there is no change in the mass, since distance is in the denominator. So force will become, suppose distance is doubled, it will become 1/4 Pranavi.
Won't it become half?
because square is there, no, for the distance
Oh,
square.
okay.
So in the denominator, suppose for example, let us take original equation is f is equal to g m1 m2 by g m1 mm by r square. Suppose both the masses are same. Suppose distance is double means what will happen is g m m by suppose 2r square will get, no, 4r square will get 2r whole square. In the case
Sir,
of r,
but it will be 2r square, right?
two distance r is 2r, you know, right?
Oh, okay. Okay, yeah, got it.
Now what will happen is this equation, this is F2, this is F1. So F2, second case force, I can write this equation as 1 by 4 into G capital M small m by R. So
Yeah.
G capital M small m by R square is nothing but F1. So F2 is equal to 1 by 4 F1. So which I can write it as F2 is equal to F1 by 4. Understood, right?
Yes, sir.
Suppose similarly, if distance is half, it will become 4 times. Force will become 4 times.
Okay, understood.
Yes. Because square is there.
Yes, sir, I understood.
So now here, these are the signs which we have to take. The equation of motion of freely falling body, u is equal to 0. We already know a is plus g because it's towards the earth, in the same direction of the gravity, plus g. So that's right. And s is equal to whatever the distance traveled is nothing but the height from where it started falling to the ground.
Yes, sir.
And similarly, to get the equations of motion for vertically upward projected body, means if you are throwing any body from the ground upward, automatically gravity will be in opposite, whatever the acceleration is towards opposite direction to the gravity. So it will be minus g, v is 0 because finally the body moves and finally it stops at some point. So final
Yes, sir.
velocity, in that case, initial velocity will be there, but how much it is, that depends on the question.
Yes,
Initial,
sir.
in u we cannot take anything. V will be 0, a is minus z, and s is equal to again h, how much, whatever the distance traveled from the point where we thrown that to the where it stopped.
Okay, sir.
Yes. So here similarly differences between g and small g can be small g and capital G. So g is acceleration produced by the freely falling body under gravity, whereas capital G is the gravitational force between two bodies of unit mass separated by unit distance. Already yesterday we defined
Yes,
that
sir.
capital.
Sir,
So
I understood this. You can just read it. You don't need to explain it.
okay, okay. So G is different at different places. So whereas capital G is same at every point in the universe, then the value of G on the surface of the Earth is 9.8 seconds square. The value of G, capital G is 6.673 to 10 power minus 20. 10 power minus is missing. 10
Is it
power minus
minus 11?
10 power minus 1 meter per kg square. And throughout the universe, it is same.
Yes,
Then
sir.
the next point is the value of G is 0 at the center of the earth. The value of G is not 0 at the center of the earth or anywhere else. Okay, Pranam?
Yes, sir.
Then finally, difference between mass and weight. Pranam, we already know that mass is the quantity of matter contained in a body is called as mass, whereas weight is the force with which the earth attracts a body towards the center is called as weight. Means what, mass into gravity is weight
Yes, sir.
of the body. So yes, the mass of the body remains constant, whereas weight of the body changes from place to place. Because when the gravity changes, the same body will weigh different.
Yes,
Different.
sir.
So mass of the body is never zero. Weight of the body can be zero at the center
Yes,
of the.
sir.
When it has mass at the center of the gravity is zero, so weight will become zero. So mass is a scalar quantity, means it's just a magnitude but no direction, whereas weight is a vector quantity because it is towards the, like it depends on the gravity, no? So because of that reason, it's a vector quantity. It has
Yes,
both
sir.
direction. Then mass is measured in kg, whereas weight is measured by weighing. Weight is measured in kg weight. That unit that is.
Yes, sir.
Finally, mass is measured by a beam balance, whereas the device that is used to measure only mass is probably beam balance, whereas weight is measured by weighing machine or a spring balance. Okay, is it okay?
Yes, sir.
So finally, kilogram force or a kg weight is a gravitational unit of force. Okay. Kg weight here is or weight is measured in kg weight. Kilogram force or kg weight is a gravitational unit of force actually. M into G. That one. Okay.
Okay, sir. Yes,
Uh,
sir.
Noted by a symbol kgf for kilogram force or kilogram weight. Mathematically, it is equal to force acting on a body of mass 1 kilogram when it is acted upon by the acceleration due to gravity. Force acting on a body of mass of 1 kilogram. Same way, Pranavi, how to define kgf is that will take the mass as 1 kg and whatever the force acting on the body of mass 1 kilogram, whatever the force acting on the body of mass 1 kilogram, that when it is acted upon by the acceleration due to gravity is the 1 kg.
Okay, sir.
Simply in that m into g is saying F is called m into g. In this place, g is 9.8 now, and m is 1 kg if you take no, we will get the answer as 9.8 Newton. No? Yes, sir, Nobody?
Yes, sir.
9.8 Newton is taken as 1 kg. Means simply to tell if mass is 1 kg, whatever the force acting on the body due to the acceleration due to gravity is considered as 1 kg.
Okay, sir.
Now we have numericals. From this, these ones only will do for me, or like which ones you will do for me. 3, 4 subs will do for me continuously so that you will get some idea.
Okay, sir.
Okay. So first one is this will read the question. Okay.
A car falls off a ledge and drops to the ground in 0.5 seconds. Let G be equal to 10 meter per second square for simplifying the calculations. What is speed on striking the ground? What is the average speed during the 0.5 seconds? How high is the ledge from the ground?
Yes. So Pranavi, car falls off a ledge and drops to the ground at 0.5 seconds. So we already know Pranavi time is given here. Now G is 10 meter per. So whenever the G is given as 10 meter per second square, we should take that Pranavi. They don't mention anything, we should take 9.8.
Okay, sir.
Then first testing this. What is the speed on striking the ground? So when so Pranavi, it just drops this end, falls off a ledge and drops
So
to
it's
the
a
ground.
freely falling object.
Yes, but it just falls off a ledge. It's by mistake, some happening and it just fall away. So here u is 0 at the start of falling, and automatically when it comes closer, it will get some velocity and because of which force also. Now, what is the speed on striking the ground? They're asking. So we know that Pranavi, whenever initial velocity and g values are known, acceleration and initial velocity is there okay, for us, the given question. So if they ask us to find out the velocity, final velocity, so we have to do u plus 80. V is equal to, because v is equal to u plus 80 generally is used to find out the final velocity.
Velocity.
Yes, Pranavi. Final velocity after some time of travel, and acceleration and initial velocity is there. We
So would we
simply
need to take G instead of A, right? Because it's a freely falling object.
yes, Pranav. This I gets
And
replaced with
U
G.
is 0.
Yes, Pranav. That is correct. So U is 0 no. In this equation, A gets
So
replaced
V
with
is equal to GT, which is 10 into 5, 0.5, so 5.
correct. This what I'm trying to tell is Pranav, V is equal to U plus 80. We should use it when we have initial velocity, time, and acceleration values to find
Yes,
out the
sir.
final.
Yes, sir.
Okay. And now what is its average speed during the 0.5 seconds? So on that day I did one mistake. Pranav. Average speed is nothing but the
Total distance by total time.
yes. Pranav. So here for that, or we can do v plus u by t also. Sorry, v plus u by that also we can do. Here what we do that one. Yes. Average is generally when you add average of two things, you will do suppose average of 5 by 3 means 5 plus 3 by 2. Okay,
Oh, yes, sir.
like that. So here average speed is nothing but the one which you said is also correct. That is total distance by total time. But since we don't have the distance, yeah,
Yes, sir.
that is the reason why another way we can do it. Yeah, normal average definition is sum of observations by number of observations. Like that, here both with initial velocity we have and final velocity we have, no? And time of travel we have. Sorry, time not.
So
With
we'll just write v plus u by t, v plus u by 2.
two quantities we are adding, so average with division.
Okay.
Average velocity is equal to 5 plus 0 for v plus u by v plus u by 2, which is 5 plus 0 by 2. 5 by 2, which is 2.5 per second. The one which is a total distance by total time also we can look at it, but here we don't know the total distance, so that's why.
Yes, sir.
Okay, correct. Now, finally, we have a distance travel. We can find out the distance travel also.
They ask the height.
Yes, height is nothing but
Height
in
is the
this.
distance because it's free fall.
Yes, the whatever from place where it started falling to the ground, we consider it as a height.
Yes, sir, I understood. So we'll use
S is equal to ut plus
ut
half at
plus half at square.
yes, 0 into 0.5. Anyways, this part will become 0. Half into gt square. So S is equal to half into 10 into
Uh,
this part became 0. T square is like 0, 1 by 2 into 1 by 2, 1 by 4. Okay, Brahmani? So which is S is equal to 5 by
there isn't 0.5 square 0.25.
2. Yes, Brahmani. 1 by 4 is also anyways 0.25. We can do that also, and because just to decimal means again it will confuse. Means I
Okay. Okay,
then
sir.
here 0.25 into 5 also same.
Okay, sir.
So we get 1.25.
Okay.
1.25.
Sir, can you check if it's correct?
Yes.
Yes, sir, it's correct.
Yes.
Yes,
And
sir. Now we'll uh
this is upward rise. Yes.
yes, sir, we'll do the next one.
One question we'll do it for upward movement. This is upward. So once
Okay,
you
sir.
read the question.
An object is thrown vertically upwards and rises to a height of 10 meter. Calculate the velocity with which the object was thrown upwards, the time taken by the object to reach the highest point.
Yes. So now in this case, madam, first we'll write the given
Okay,
data.
sir, so we can find the velocity with which the. No.
Was thrown
We,
upwards. Means what you there asked. Sorry. Was velocity with which the object was thrown upwards. When the object is thrown upwards, V will be 0 for sure. U will be something. We have to provide because some force is there, some force is applied. So that's
okay.
why U will be there. Finally, it will stop at some point, so we will be 0. Okay.
Yeah.
And we will, what else is given? They clearly said height it traveled is 10.
We can use S is equal to ut
This
plus
is
half
equal
at
to,
square again
yes, G value, we should take it as minus 9.8. That is
because it's
actually
going in the upward direction.
because here actually G value is plus 9.8, but it's moving up, no? So again, it's the gravity of that. So that's why we should take it in opposite direction.
Yes, sir.
Now, what all values we have? V we have, S we have, G we have. So which equation we can use? V square minus U square is equal to 2as. That is, this
Oh,
will
yeah,
take.
we don't have time.
uh,
We
S.
don't have time.
So V is equal to U plus AT we cannot use. S is equal to UT plus operating square we cannot use. V square minus U square is equal to as we can use. Okay? So in
So
this, we
2g
can
into height.
2 minus G into H.
Yeah.
So V square anyways it will fall, it will stop at some point. So 0. U square is we need to find out minus is equal to 2 into minus 9.8 into 10.
Yes,
So
sir.
minus U square is equal to 10 into 9.98 will be 2 into 98, which is 196. Minus will get that U is equal to root of 196. Is 14 meters.
Oh, sir, but wait 1 second.
Yes.
In this step,
Yes, Prannavi.
If v square minus u square is there, you wrote 0 minus bracket open u square, right? So if you take u square, suppose there's 2. If you take u square, it will be 2, 4, and then the minus will come outside, it will be 4, right?
Minus is not inside the bracket. No?
Yeah, after the square is, if after the squaring is done, it will be minus 4.
Yes, Prannavi.
But
Suppose you
then,
put it like this, it is -4. It is like this, it is plus.
oh, okay.
That total you are asking, okay, or else any other?
Yes, sir, that only.
Means sir, this minus is not like this. Prannavi.
I understood now.
U square minus whatever u square result is, that is.
Yes, sir.
Yes, we know the time taken by the object to reach the highest point. Time taken by the object to reach the highest point is nothing but now we can use, we have both the u, v, g. T we can find out using v plus u, v is equal to u plus at. Because reason is we have v value, u value, g value.
Yes, sir.
Time is nothing but we can use the first equation. V is equal to u plus at. Or s is equal to ut plus half at square also we can use, because
Yes,
we
sir.
have s value, u value, a value. That way also we can. This is more simple because the t square is there. So v is 0, u is u1, sorry, u we got it, 14
14 plus
minus 9.8 into t. Okay,
yes, sir.
minus 4. So it's
10 into 10, 140 by 98.
is so 14 7 the 98 I think. So 10 by 7.
Yes, sir.
So 1 by 3 seconds. So which we get it as 1.4. 10 by 7, 10 if we divide with 7, 7, 7. Point that is 7 for the 28. That would be 27. 2 is 14. The third decimal will come more than 500. They rounded it to second decimal, which will come 1.4. Okay, perfect. If we
Yes,
make,
sir.
if we do it till the third decimal, we'll get 1.428, which is nothing but 1.4.
Yes, sir.
Or we can add mixed fraction 3 by 7 seconds.
Okay, sir.
Answer.
Sir, so uh, are there any other models for the like?
And here only one question is there. Maybe then they went to worksheet 1. So this is the new model. Okay. Okay, Pranali?
Which one? Third one.
Yes, because they gave 3 examples and then they started worksheet, means this is a different model.
Yes, sir.
Answer the question.
Sir, can you zoom in a little?
Yes.
A block of wood is kept on a tabletop. The mass of the wooden block is 5 kg and its dimensions are 40 into 40 into 10. Find the pressure exerted by the wooden block on the tabletop if it is made to lie on the tabletop with the sides of the dimension 20 centimeter into 10 and B 40 centimeter into 20.
Yes, Pranavi. So Pranavi, generally when the block case is Pranavi, the force applied is actually we have one more formula called like pressure force, like force per unit area is called as pressure.
Yes, sir, I know.
So in that, yes, Pranavi. So here whatever area that is in contact, that particular area we should take into consideration. So here,
Yes.
it is so the block of wood is kept on the laptop. The mass of the wooden block is given and its dimensions starting 2010, length and height. Find the pressure exerted by the wooden block on the tabletop. It is made to lie on the tabletop with the sides of dimensions 20 by 10. Means length and width of 20 and 10. No.
Yes.
Length and height are 40, 20, 10. But the surface that is in contact is 20 by 10 dimension. That is the area to be found out using 20 into 10.
Yes, sir.
That in contact with the surface. So now first question is to find out the pressure. Pressure is equal to force per unit area.
Yes,
Means
sir.
the area is 20 to 10, 200 centimeters square. So since the units we need to convert per me here because reason is centimeter is not the SI unit. Okay.
Yes, sir.
So first we'll find out the force. F is equal to M into G, but we'll write the first given data. M is how much? 5 kg. G is how much? They didn't give anything. So 9.8.
Yes, sir.
If they mention 10, then only we should take it. So it is called M. This is a force that is exerted by the weight of this mass of this 5 kg. So 5 into 9.8, which is or else if you keep it like this, also not a problem. Just you need to do division. So find the 9.8 is 95 to 450, 50, and 49. Decimal, if you keep it 49.0, which is 49.
Yes, sir.
Now area in contact is nothing but 20 into centimeter. I'm converting into meter per by 100 and 10 into 100. I understood what I did.
Yes, sir. Yes, sir.
So suppose if you forget to convert here, you will get it in centimeters square. Then you should divide with 10,000.
Yes, sir.
So then you will get 1 by 2 area, which is meters. I converted it to meters. So let us keep this like this. We know if pressure is equal to force per unit area. So force is 49 divided by 1 by 2. So it will become 49 into 50 by 1. 45 is a 200 and 5 is a 40. 2450 Newton per meters.
Yes, sir.
Correct.
So we find the area for the other two things also.
Unit strong Pranavi, force per unit area correct or here, Newton per meter square because area is meter square.
Yes, sir.
Yes, Pranavi, you are asking about the
So we find the area like that for the other ones also, 4 into 20 and 20 into 10, and then we do
because
it.
the area in contact in the B1 the area in contact is 40 by 20. So automatically the area is more. So
Yes,
40
sir.
into 20 into 1 by 100. So here area is more, so like the pressure will be less, will get
Yes.
lesser value than the before one. You want me to do Pranavi or not?
No, sir, it's okay. I understood.
Is 40 into 1 by 100 to convert to meter and another 20 into 1 by 100 to convert it to meter. So then 0 cut uh, 0 cut to 1 is to 5 is
Yes, sir, I understood.
so 2 by 25 get, and the other one is force is same here also 2 by 25. This is actually the area. Okay, Pranavi?
Yes, sir.
This is area and another value is not Pranavi. Force. Force is how much weight? We got it. 49. Same. 49 remains same, Pranavi. This
Yes,
number.
sir.
So you get it as 49 into 25 by 2. Finally, when we reciprocate it,
Yes, sir. So you don't need to solve it. We can. I understood.
you get 61.5 per meters.
Okay, sir. Sir, so are there any different models in the worksheet or is it the same models?
Most of the time, Pranavi, I think easily. But if you have the solution, if you get any doubt, Pranavi, if you have the solution, just you can easily understand the steps with this understanding for
But
sure.
there's,
But you
sir,
have
can you scroll down a little?
this one. These ones are not covered here. But before you asked one doubt, the acceleration of the gravity on the planet is 9 times the acceleration due to gravity on the planet B. So this type of ones, Pranavi, if I scroll down.
They might give the answers. Did they give the answer?
No, Pranavi, they give multiple choice
Oh,
questions. For multiple choices, they gave answers. Only option. Then assertion reasoning they gave something. I think
Yes.
only these questions, mostly if you write the given data from you will easily understand. Stone is dropped from a roof of building means it takes 4 seconds to reach the ground. Find the height of the building. Direct question. Dropped from the roof of the building means u is 0, t is given. So what we can find out is height they're asking.
V is equal to u plus at.
But anyways, v is equal to u plus at is required if v is required. Means v is equal to u
Oh,
plus at we use it if v is required. But anyways, here just they're asking the height.
height.
So we can use s is equal
S
to
is
u
equal to v square. Oh,
that is
okay.
equal to u into t plus half into gt square. So h is given, h only we need to find out. U is 0, so this part will become 0. Half into 9.8 into t square is 60. Understood, right?
Yes, sir.
So 9.8 into 8, 8 into 64, 6, 72, 78.4.
Yes, sir.
Any doubt? No?
No, sir, I understood this. Hello, sir.
Yes, ma'am. Okay.
Yes, sir, I understood.
I think the third one we will do once.
Okay, sir.
And also second one also, when a spaceship is at a distance equal to 2x radii, 2x radii from the center of
Okay,
Earth.
so we just need to make multiply the distance into 2.
Yes, the distance, the distance will get it, but they're asking find gravitational.
Acceleration.
Yes,
So small g.
yes,
So wait, we can write F is equal to m into g.
it's called a metal. Okay. Actually, when we here g is equal to, you can use, they're asking g is equal to g capital M by r square. So the distance is 2x means it doubled.
Yes, sir, that's what
Distance,
I said. We can double the Earth's distance and then find it out using that formula.
yes. So force will become 1/4. So that is g value will become one fourth of it.
Okay, so g value is 9.8. So we just write 9.8 by 4.
Because Pranami, this which equation we can use to find out this Pranami?
F is equal to g m1 by m1 m2 by r square.
Suppose if we use that,
But then we don't have small g in there, right?
yes, Pranami. Later we got one equation of Pranami by equating mg is equal to jm1 m2 by r square. G we got it as g capital M by r square. That one we should use here.
G is equal to g a capital G m by a capital M by r square, right?
Yes, Pranami.
That's the equation we got.
Yes, Pranami, that is correct. That one if we use, we'll get it.
So can you solve it once?
Ah, yes, Pranami. So here we have the given data Pranami. Suppose g is equal to g capital M by r square. So this is constant, no, Pranami?
Yes, sir.
So what will happen here? Simply, we can use it's a direct one. Pranami. We can even tell 9.8 by 4 directly also. Why? Because like I said, this doubled. I'll write
Yes.
more clearly with an equation. So then we first
Sir,
g is equal
actually, I have a doubt here.
to s Pranami. In the
Uh,
second g
when
dash,
when here you're multiplying it with 2, then if you take it here, won't it become 2g?
where Pranami?
Sir, you can't see the annotation.
No, no, Pranami, I didn't see it. These two gets cross multiplied. You're telling, no? this 2 will come this side, you're doing, no?
Sir, 1 second. Yes, sir. If you take 2 over here, you multiply it with r square, and then when you take it here, won't it become 2g?
Yes, Pranami, but in the R place, we need to write 2R whole square, no? In the
That's
R place, in the R place, we need to write 2R whole square, no, Pranami?
no. Won't we just write 2r square?
No, 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 no. R is the distance. So this time distance is doubled. So 2R. Suppose R is 5. Now present distance is 10. 2 times of that. So like this it will come. Okay, Pranami?
Yes, sir.
So we get 2.45 meter per second square. Okay.
Yes, sir.
Understood, Pranami, how I solved it?
Yes, sir. I understood. Are there any other models, like other important models?
Third one also similarly we can do it in the same way, but I think this if you understood that also you can easily understand. If you have the solution, you can just the observation you will easily understand it.
I don't have the solution.
So, so this one you have any doubt for me? What I need, this is the actual G.
Yes,
What I
sir.
did GM by R, GM same here
I
also.
understood this, sir. You can explain the next one.
Okay. So find the acceleration due to gravity on the planet A is 9 times the acceleration due to gravity on the planet. So here also Pranavi, G is equal to G capital M by.
R square.
So on a planet A, 9 is 9. The acceleration due to gravity on a planet A is 9 times the acceleration due to gravity on the planet B. So the question is not completed. A man jumps to a height of 2 meters on the surface of A. What is the height of the jump by the same person on planet B?
Sir, so
So
acceleration due to gravity, first we can write for planet A, we can write G1. Um, so 9 into G1 is equal to, no, we can write on acceleration due to gravity on planet 2 as G2, and then acceleration of due to gravity on planet A is G2 into 9.
like this, G1 is equal to 9 times G2. Okay.
Sir, they're not equal. They didn't say that they're equal, right?
Is not. This is this one.
Oh,
Acceleration due to
okay.
gravity is 9 times. Okay. A man jumps on a height of 2 meters on surface A. So first this
Sir, I
formula is
don't think we need to write G1 and G2 because it's the same thing but into 9 times.
yes, Pranali, that is also better. So J is equal to 9. No, 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 no. It's better to use for it because if this is or else this one you need not write any name. Like if you take that as x, this is 9x like that. Okay.
Okay.
So G1 is equal to 9G2. Let us take. This is Gn by R square. This is G mass. Mass they didn't mention anything.
Yes, sir.
Planet B. So 9 times acceleration they said. So mass we can take it as if they said that 9 times gravity means 9 times no. Okay, so actually due to gravity on the planet X. So then we actually my mind is not because the next year student is messaging to our
What, sir?
the next year student is messaging to our Twitter and my mind is not working. So Pranavi, shall I solve this one and shall I send the picture Pranavi?
Okay, sir.
Okay, Pranavi. Actually, the student maths tomorrow maths exam. So continue. I just message you.
Okay, sir.
Okay, Pranavi. I'll send the picture Pranavi solution.
Okay, sir.
Okay.
Bye, sir. Thank you, sir.
You have, I think you understood it now, Pranami. Most no, I think the gravitation part.
Sir, can you solve it once and send it?
This one I will send it for me, but overall the chapter you understood it now.
Yes, sir.
Okay.
Okay, bye, sir. Thank you, sir.
Very much.